Hello and welcome back to Curtitus Math. So this is video number 11 in the science option preparation video series. We are starting a new unit in this video. So this is the third and final unit for the preparation, is rational expressions. So there's a few subunits or subtopics, I should say, within rational expressions. The first being complex fractions and restrictions. Then we're going to do multiplying rational expressions, dividing rational expressions, and if we have time, that's why we have a little star, adding and subtracting rational expressions. We might not be able to get there in terms of like a package that we will be collecting, but I will be putting out a video, and if you would like to watch it and kind of just get an idea of what adding and subtracting rational expressions looks like, you can absolutely do that at the end of June or throughout July if you want to just kind of get ready for next year. Absolutely up to you. That will be available to you. So just a little thing to mention, I should say, about rational expressions. What rational expressions are is essentially fractions with polynomials. So you're going to get things that look kind of crazy, something like 3x squared plus 2x over 4x squared plus 1 times 5x, like stuff like that. They get pretty involved. So you're dealing with a fraction and you're dealing with algebra all at the same time. So you need strong foundational fraction abilities, and then you also need to be able to manipulate your algebra quite well. So those are two things that students generally struggle with. The main part being just kind of the conceptual foundation on fractions. So you do fractions when you are quite young. So I feel like a lot of it's maybe you remember steps, you remember procedures, but you might not exactly understand why those steps and procedures are in place, which is exactly what this video is on. So this video, we're not actually going to get to restrictions because we have quite a bit to talk about in a short amount of time. So we're really just going to be dealing with complex fractions and really like just the idea of what a fraction is, and we have to go a little bit, we have to backtrack a little bit in our math knowledge to really get into the nitty-gritty of what a fraction is and how to deal with it. So this video will only cover questions number 1 to 8 in the package, since those are all of your complex fractions that don't have any algebra involved. The next video will deal with the algebra. So let's jump right into it. So just to refresh our memories, something like, let's go with something simple. So 3 over 4. So a fraction, we can look at it quite a few different ways. So we know that a fraction is a form of division. So that's one thing, is that we do have a division happening here where 3 is the dividend and 4 is the divisor. And the answer to this division would be considered a quotient. So when you have something like this, an improper fraction, where you have 24 over 6, your numerator is larger. You're at a number that's larger than 1. So your quotient is going to be a number that's bigger than 1. But in this situation, your number is smaller than 1. So if you have, you can see this, this can be visualized a few ways. You can see it as you have an entire thing, a whole, that's been divided up. It's been cut into 4 pieces. And you have 3 of those pieces. So you can visualize it that way. You can also visualize it as you have 3 separate identical objects. And we are trying to share these 3 identical objects 4 ways. And we can't do that, so we need to separate these 3 into 4 groups. And we can do that by, so we cut this one this way, we cut this one this way, and we cut this one this way. And by combining some pieces, so this becomes your 1 piece, this and this together, when you add them up, becomes your 2 piece. Then you have your, I'm not describing this very well. Let me color code them. I think that'll make more sense. So this is piece number 1. This is piece number 2. This is piece number 3. And then this is piece number 4. So you have taken 3 things and you've divided them up into 4 equal sized pieces. What size are those pieces? They are this much, which is 0.75 of your original whole piece, or 3/4 of the whole piece. So there's different ways to visualize it. You can see it as you cut up one thing into 4 and you have 3 of those pieces, or you actually divided up 3 separate things. So that's where it gets confusing, is that it can mean different things depending on the context. Okay, and then another thing that's important to understand is there's different ways to conceptualize what a division is and what it means. So there's these 2 fancy words, quotative and partitive division. So these are some examples with whole numbers. Okay, so here we have 8 divided by 2. And in the quotative version of division, we're essentially asking ourselves the question, and I will take the little curtain away here. We're asking ourselves the question, how many groups of 2 can we make from 8? That's our question here. So how many groups of 2? Well, let me see. I'm going to group up my 8. I have a group of 2 here, I have a group of 2 here, I have a group of 2 here, and I have a group of 2 here. So I have 4 groups within 8. I have 4 groups of 2 in my number 8. So that's quotative. The other way that I can conceptualize division is in the reverse, is instead of looking at the groups, I ask myself how many elements I have in a group. So here, if instead I ask myself how much in each group when we split 8 into 2 groups. So I'm doing the reverse. So now I'm splitting 8 into 2 groups, one here and one here, and I'm interested only in what's inside one group. I have 4 things in each group. So this is 4 things in each group when I split it into 2 groups. And this is 4 groups when I put 2 things in each group. So it's the reverse situation, but you notice that the result is the same. The numerical result is 4 and is 4. The context is different though. In quotative, I'm talking about 4 groups, and in partitive, I'm talking about 4 things. So it's actually a different result. However, numerically, it presents itself the exact same way. Okay, so that's kind of one of the interesting things about division. And this happens because the way that we got 8 is we took the 2 and we multiplied it by 4. And we don't actually know which one here is the number of groups and which one is the number of things. Did we actually start off with 2 groups and 4 things each, or did we start off with 2 things each and 4 groups? We have no idea. We just know that the end result is 8 things in some kind of situation. So now, oh no, there's spoilers in there. Okay, well, I guess we'll roll with it. So now we're looking at the same situation, the quotative and the partitive, but we're looking at it with a fraction division. So a division of fractions, and trying to see, well, how does this translate from the 8 divided by 2 example in a fraction division example? And this is what we have here. So in the quotative, we're using the exact same wording. So up here we did how many groups of 2 can we make from 8? So we took the divisor, and the divisor was our groups, right? So here we're asking the same question. The divisor is 1 over 4, and we're asking how many groups of 1 over 4 can we make from a half? So we're going to answer that question. We're going to draw it out. So let's get ourselves a little circle. I'm going to put in, so I'm cutting it here in half. And so we have a half, right? We're starting off with a half. Let's shade that in. That's right over here. So that's a half, and we're asking ourselves how many groups of a quarter can we make? So in this shaded region, how many groups of a quarter do we have? Well, we have 1/4 here, and we have 1/4 here. So how many quarters do we have in a half? We have 2. There are 2 groups. Okay, so quotative does work in the fraction representation. The issue we run into here is this situation, is the partitive. So in this version, so again, this is the exact same setup that we asked ourselves before. Here we said how much in each group when we split 8 into 2 groups. So we took 8 and we cut it up into 2 groups. And we're counting the number of things inside. So in this case, we're asking ourselves how much in each group when we split a half into a quarter groups. So how much in each group when we split a half into a quarter groups? But what is a quarter group look like? What is this question even saying? Its English doesn't make a lot of sense. So the question here, when we have a fraction division and we want to express it in a partitive way, the question changes a little bit because this question format doesn't make any sense. It's not telling us anything. What is a quarter group? What does that even look like? What this is actually asking us is what number or what amount, I guess we can say, what amount is a half the quarter of? So this expression, this question, is showing us that a half is the result of something being cut into 4 pieces. So we started out with something, it was cut up into 4 pieces. It was separated into 4 groups. And that result gave us a half, and we want to kind of work backwards. So how do you reverse this? How do you figure this out? Well, you have to do the opposite. You need to multiply. Need to multiply. And this is exactly the reason why these are equivalent statements. A half divided by a quarter is the exact same statement as a half times 4. For this reason is I'm asking what answer, what value was cut up into 4 pieces to give me a half. Well, if I do this, if I go backwards, I will get that answer. It was 2. So if I had 2 things, So I guess we'll stick with circles. So let's get two circles out here. So if I have two circles, and now out of these circles, I cut all of this up into into four equal pieces. I have one piece, I have two pieces, I have three pieces, I have four pieces. What size are those pieces? They're size 1/2. That's what happened. So that's why the reverse here happens. So this is really just the kind of conceptual like background of fractions and of dividing fractions and what all of that means. So now going into these examples, so I'm going to do a couple of these. So we'll do one, we'll do two, just to, and then we will do 6, and then we'll see how that goes. Okay, so here we have 1/2 over 5/4. So all of this can be translated into a division statement. So you can kind of circle your fractions. So you have two fractions and then one fraction over the other. So you can rewrite this entire statement 1/2 divided by 5/4. And then this over here can get translated to a multiplication. So 1/2 times and then 4/5. So that is the rule, and that's what you have seen up to now, is that when you are dividing fractions, the division changes to a multiplication, and then the second fraction flips. And the reason for that is exactly what we saw here, is this question format. So because of this question, this is why these are equivalent statements. So that's why we can do this. And then when we're multiplying fractions, we multiply straight across. So we have 1 times 4, we get 4, and we have 2 times 5, which is 10. And then this can be simplified. So if you have 4 out of 10, that is the exact same thing as having 2 out of 5. Okay, and that you can see in a little pizza slice. So over here, if I cut this up into, I'm going to try my best here to get 5 equal slices. It's not great, but it'll do. So here, if we have 4, that's the same as if I had erased some of these lines and combined the pizza slices. And then we would have had 2 out of 5. So each, I'll back up there. Each slice here, each group of 2 slices got combined, but we haven't changed the meaning of this. Okay, so the next one is the same setup. So we have 4/9, and that's being divided by 4/3. So this changes to a multiplication, and as a result, this has to flip. So this situation of changing the division to times and then flipping your fraction, those two actions essentially cancel each other out. They compensate. One compensates for the other. And then here we can multiply straight across. And another thing that you can notice here is that you have a 4 on top and a 4 on the bottom. When you are multiplying, you're able to cross these out. And you're able to cross them out because it's not magic. There's a reason why you can cross them out, is because this is 4 times 3, and then this is 9 times, well, I mean, that's exactly what we wrote, but some of you might know the word commutative, which means that multiplication you can flip, you can kind of move things around, it just means that something like 2 times 3 is the same as 3 times 2. That they mean the same thing. So I can move this 4 over because we're multiplying. So I can put that here. And then what is 4 over 4? If I broke this back up after, if I change this again, I now say 4 over 4 times 3 over 9. 4 over 4 is the same thing as 1. 1 times 3 over 9 is 3 over 9. So that's why you can cancel these out, and you can just write your answer is 3 over 9. Okay, so that's our multiplying. Multiplying fractions is the easiest thing to do out of all the things that you can do with fractions. Adding and subtracting is the more difficult thing, which I find interesting because it's actually the thing that we start with when we teach you fractions. It's one of the harder things to do. So something to remember is that the bottom number here, our denominator, indicates what size piece we have. So here, when we have 2 over 9, we mean that our little circle guy is, how am I going to draw a 9? 2, 3, 4, 6. Nope. I'm trying my best. Okay, I kind of did it. They're not equally sliced, but it's my app can't do those. Okay, so the size of these slices is, it's a thing that was sliced up into 9 equal pieces. So the size of my slice here is 1/9. I have 2 slices of 1/9. Okay, and then this fraction, 6 over 25, which I'm not going to draw, or we can kind of guesstimate what one slice would look like. It might look something, or maybe not that tiny, but it might look something like this. So the size of this is completely different than the size of this. They are not the same sized slice, which is why adding the top numbers, so if this is size 1 out of 25, adding these top numbers, 1 plus 1, it doesn't make any sense because you're not adding the same thing. This is a 1 out of 9 size, and this is a 1 out of 25 size. You can't just combine them. So the only way to do it is to turn them into the same size piece. So you have to slice up this 9 guy enough ways to make something different, and it might be a new number of pieces. You're going to have more pieces out of a different number. But then at least the top number that you end up with is actually something that is the same size piece as the other one that you're working with. So that's the idea with common denominators and why we need common denominators. So here we want to start off with, we're just going to start with doing this entire addition. So to find a common denominator here, the easiest way to do it is to multiply by whatever, just kind of swap their denominators. So on this side, I have a denominator of 9. So I'm going to multiply the top and the bottom by 9. So notice that I haven't changed anything because 9 over 9 is 1. So no magic here. I'm not changing anything. I'm just rewriting this in a convenient way. So I'm now taking all of these 25 slices, or size 1 out of 25 pieces, and I'm taking each slice and I'm slicing it again 9 times. So each slice is getting sliced 9 times. And then the 6 pieces that I already have that are of this size, I'm slicing those 9 times. And now I'm going to do the same thing to my 9, is that I'm going to take my size 1 out of 9 and I'm going to slice this 25 times each slice. So this is going to get multiplied by 25. And then these two pieces that I have, well, they're both getting sliced by 25. And again, on this side, I have not changed anything at all. I am multiplying by 1. I'm just rewriting my fraction in a more convenient way. So this is going to be 50 over, and that I can't do in my head. So let's grab our little calculator here. 25 times 9. We have 225 plus 6 times 9 gives us 54 over, and this denominator is going to give us the exact same thing. That's what we want, 225. And now, remember that the only slices that we actually have is the top number, right? We have 50. We took these two, 1 out of 9. We sliced them, each slice 25 times each. So now in total we have 50. But that's all we have. That 225 just means that my entire pizza has 225 slices. We don't actually have this number. This number just means what size my top number is. So this is why you don't add, you don't touch the denominator. The denominator is just there as an indication of what size your slice of your fraction is. The top number is the only thing you have. So when we're adding, we are only adding the 50 on top and the 54. So we end up with 104 over 225. So we've merged them, we've combined them all together. And then just a little note that you can use your calculator to simplify a fraction. I don't believe that this one can be simplified, but we're going to check anyways. So 104, punch in your fraction button. It would look like an A over B, or it might look like a B over C. It should give you kind of like a little R. It'll look like this on your calculator. So if you type it in, it should look something like this. And when you hit enter in fraction form, it will let you know if it's simplified. So that's something that you can use. In this case, it is already simplified, so we're just going to rewrite this now. So now we have 25 over 104 over 225. So this is something that we can rewrite. So this can get translated as 25 divided by 1 over 4 over 225. And then this will get translated. So the division turns into a multiplication, and then our second fraction will flip. 225 over 104. And then this gets multiplied. So times 25. Oh boy. Answer times 25. So here we end up with 104 over 9. So, and I got 104 over 9. You might be wondering, where did that come from? So I typed it in directly on the calculator. If you wanted to do it step by step, so let's erase this, 25 times 225, we would have 5,625 over 104. And then in your calculator, you would type this in using your fraction button, 5,625 over 104, and your calculator will simplify it for you. This is not something you have to do manually. So over 104, you hit enter. Why is it? Oh, you know what? I think that my calculator might have not done order of operations properly. Let me check this again. 25 times, and then brackets 225 over 104. syntax error. Yeah, my calculator had done it wrong, so it's a good thing that I actually typed this in again because this is not 104 over 9. That's not your answer. This is your answer. It cannot be reduced. So always double check your work. Okay, so let's get rid of the calculator for the moment. And we'll do one more. We'll do one with a subtraction and one with something going on in the numerator. So we'll do this one here. Oh, and actually this is a good example. So first things first, we're going to deal with that numerator with the subtraction. So we have to we have to subtract, essentially. So we have 1 over 5 minus 4 over 9, and we need our common denominator. So we're going to do the same thing we did in the other example. We're going to multiply the first fraction by 9 over 9, and we're going to multiply the second fraction by 5 over 5. And we're not changing anything, we're multiplying by 1. So in the first one, we're going to get 9 over 45. The second one, we have 4 times 5, 20, over 9 times 5, 45. And now we are only dealing with the numerator. So 9 minus 20, we end up with negative 11 over 45. Okay, so now we can rewrite the original expression as negative 11 over 45 over 16. So when we rewrite this as a division, we have negative 11 over 45 and then divided by 16. So at this point, you might be wondering, well, how on earth do I do this? I can't flip it. We need to remember that every number under the sun is actually a fraction in disguise. So 16 is over what? If I forced you to put a fraction line here and put a number under there, what would have to go under the fraction line? I'll give you a few seconds to think about it. Is your answer 1? Your answer should be 1. So we do have a denominator under there. The denominator is 1. So we can actually do our little flipping action. So when we rewrite this, negative 11 over 45 times 1 over 16. And this is actually a very important idea, is that dividing by a number is the same thing as multiplying by 1 over that number. Representing dividing like this is a very, very important skill. And actually, just as a little side note, you might have noticed area of a triangle. Sometimes you'll see base times height divided by 2. Sometimes you'll see it written as a half times base times height. And this is this exact idea. This divided by 2 business is the same as a half. So just a little side note. So I would say getting comfortable with this notation of division is very important. Okay, so now actually doing the multiplying, we multiply 11 times 1, 45 times 16, and you might wonder, well, what happens to that negative? The negative comes along for the ride. We have a negative. It's your entire fraction is negative. You could see the negative as belonging to the 11. You could see it as belonging to the 45. It's just, it belongs to kind of the entire unit. So it's best to either kind of put your negative like in line with the fraction line, or if you're going to give it to one of the two, numerator or denominator, it's best to put it in the numerator you don't really see it written as belonging to the denominator. You can, and there are specific cases which you'll see next year, um, specific formats of some things where you do want to kind of keep it in the denominator, but that's in very specific situations. Normally, you're either going to keep it kind of like this where it belongs to the whole fraction, or you're going to give it to the numerator. So in this case, we're just going to leave it. We have a negative entire fraction times a positive entire fraction. So we know our answer is going to be negative. And now we have 11 times 1, which gives us 11. And then 45 times 16, that is not something I can do in my head. 720. Okay, and we can check just for fun if this can be reduced. It might actually. Actually, no, it's not. Yeah, it can't be reduced. And that would be your answer. So negative 11 over 720. So I'll just move this. Okay, so that is it for this video. I think it has dragged on a little bit. It's quite long. But there's some very, very important ideas here, especially with these questions. And just I would encourage you that every time you deal with some kind of division, you kind of just try to think about the problem in these two different ways and see the context of your problem. Which situation are you in? Are you looking at a quotative or are you looking at a partitive? Just to see if you can get that questioning in your head as you work through division related problems, since that is a very important skill. Okay, so I will see you in the next one where we're going to continue with section 3.1. So we're going to talk about what restrictions mean and dealing with variables within a fraction. Okay, so I will see you in the next one.